Good morning and welcome to another Snowpocalypse snow day lecture. So we're just going to wrap up this lecture from week 9. Just a few things left. It's hemispheric lateralization, memory and encoding, and then consciousness, which is to say the reticular activating system. That's all we've got left. This should actually be relatively quick for you. So this is about where we left off. We were talking about hemisphere lateralization, and I took this picture from the internet as sort of our cultural awareness of what our two different hemispheres do. There's sort of a stereotype that, okay, people who are left-handed, they're controlled by the right side of their brain. That means they're creative, they're musical, they're artistic, whereas most of us are right-handed and we're controlled by our left brain, which is analytical, reasoning, math, things like that. That's not accurate. There is such a thing as hemisphere lateralization, but it doesn't mean that if you're born left-handed that you're magically going to be a wonderful artist, or that if you're born right-handed you're going to be an analytical person. All it means is that we have a right and a left hemisphere, and there is a little bit of a divide and conquer in terms of function, but it's nowhere near the stereotype culturally. So again, there's cerebral lateralization. That means you have two different hemispheres that we've given these names of the left hemisphere is categorical and the right hemisphere is representational. And we'll get into that in just a second. I just want to go back to this vocab word right here. Pretty minor. Petalius just means that you are not symmetrical. In fact, if you've ever looked at like let's say a cell phone camera that switches your face around and suddenly you're looking at yourself the way other people see you and you're thinking, I look really asymmetrical, I look terrible, what the hell, is this what everybody else sees? The answer is yeah, unfortunately. They're used to it, they think you're gorgeous, don't worry about it. But actually our entire cranium, our entire facial structure does have this shift. It's a sort of a right shift, sort of a, let's see, from the top it would be counterclockwise shift, so that your bones, your cranium, your facial structures on the right are all a little bit anterior, and the ones on the left are all a little posterior, and that extends into your brain as well. That's something we could see in certain imaging tech modalities. If somebody's lying down in an MRI machine, all of this is going to be kind of sloshed back a little bit. There's not a ton of space, but there's enough. But it may not be as recognizable on an MRI, but we have recognized that there's this shift on that midline. And that's just the vocab Petalius. That's literally all you need to know about it. I don't think there's any significance aside from the fact that, it's our entire face that's shifted like that. It's just normal. We don't like being asymmetrical, but we are. Okay, so let's go back to this idea of lateralization. You have two hemispheres. The left hemisphere is generally considered the dominant one. Most people, 95% of the population. I heard it was more like 10% of the population is left-handed, but what do I know? Left hemisphere is categorical. Now, really, we this your textbook is still kind of going into the stereotype of it's analytical, it's reasoning, partitioning information into small fragments for analysis. I think what's really significant about it is Wernicke's and Broca's areas are there. Remember, they're only in the left hemisphere, which seems a little bit weird, right? You only have it on one side. What's going on in the right hemisphere, we're going to refer to that as the representational hemisphere. And there is maybe some accuracy where you're going to have some more musical skill on this side, artistic skill, comparing sight, sounds, and smells and tastes. Sure, why not? Um, that doesn't mean to say that this makes you artistic and this makes you analytical, right? So here's the thing with this lateralization. Remember, we only have things like the corpus callosum and other sources of commissural fibers connecting the right and left hemisphere, sorry, left and right hemisphere. So what this means is if you've got more commissural fibers, if you have a larger corpus callosum, you have more communication between the categorical and representational hemispheres. That means you have more access to your understanding of, let's say, what words are and what words mean is really what's going to happen on the same region of the opposite hemisphere. So I'm going to repeat that and I'm going to rephrase that. Wernicke's is over here on the left. Over on the right, they're saying musical ability. I'm going to kind of simplify from what they're saying. Um, what words are over in Wernicke's, understanding language, and then I'm going to go and say over here is more about understanding emotional content of language. So we don't have a Wernicke's on this side, but we're still going to have something sort of linguistic happening that's a similar but more of a supportive function on the opposite side, if that makes sense. So I'm just using Wernicke as an example of similar but supportive, right? So you're going to have something where you can maybe understand the emotional content of language. And the way that I usually demonstrate this is um, the difference between saying, do whatever you want, honey, and do whatever you want, honey, right? It's like a dangerous thing. So there's actually an argument. Women tend to have a larger corpus callosum than the male population, and it's on average, so it's not always going to be true. But on average, women have a larger corpus callosum connecting right and left hemisphere, and men have a proportionally smaller one, typically, again. And that means that, maybe when you said do whatever you want, honey, your significant other, if they're male, happen to go, yeah, okay, and go out and drink with their buddies instead of paying attention or whatever it is they needed to do. So that's sort of the joke, but that demonstrates this idea of hemispheric lateralization, where you have certain roles in the left hemisphere, supportive roles in the right hemisphere, commissural fibers connecting those regions, right? So you need to have that connection in order to make those emotional connections to the logical thing that happened over here. And again, this Wernicke's versus musical ability, creativity, emotional understanding of words that's over on the right hemisphere, those are actually pretty extremes in terms of how different these roles are. The rest of it, it's all pretty similar, right? For your precentral gyrus, for your postcentral gyrus, the right and left functions are identical. We're not going to say that, this hemisphere postcentral gyrus has emotional impact for your somatosensory reception. That's not accurate at all. So that's really it for hemispheric lateralization. Make sure you can define representational and categorical. Understand that Wernicke's and Broca's are just on the left and that there will be supportive roles on the right that may have more emotional understanding of those things. Again, we're going to communicate between the two hemispheres via that corpus callosum, which has commissural fibers. And then we'll move on to the topic of memory already. I have, again, added some slides into memory to actually give you some real insight into what memory is in the brain. The original slide for this was this. This is what we used to be limited to in this lecture, and I don't really think this is adequate because this is exclusive to episodic memory, remembering a fact, remembering a thing. So let's go ahead and go through this. Memory involves a lot of components of the limbic system. Hopefully, you've already studied the limbic system from last week and learned about the hippocampus, the amygdala, the hypothalamus, the cingulate cortex, their roles and how they interact. So we're going to see some of those again. Now, for episodic memory, remembering a thing that happened or things that happened, events in your life, we are going to have some ways that we classify the episodic memory. First, there's going to be a stimulus, and you're going to have some kind of sense that is going to perceive it. Maybe you saw it, maybe you heard it, maybe you felt it. And then very briefly, you have a sensory memory, which is to say for just a millisecond, you remember how that thing felt that you picked up. If you happen to pay attention to that thing, then it may go into short-term memory. Maybe think of this as in terms of like you're baking, where did I put the eggs, right? Short-term memory. It should only last about less than a minute. If you repeat your short-term memory to yourself, there's a chance that you could encode the memory into long-term memory. You probably aren't going to repeat where I put the eggs repeatedly. You're not going to be thinking 3 days ago, oh, the eggs are on the counter. 3 days from now, hopefully you did not repeat that enough to think, oh yeah, those eggs were on the counter. That doesn't really serve you very well. So with attention and repetition, you can encode these significant things into long-term memory. Now, so far, this sounds really intuitive. There's nothing really surprising here in my experience. Um, Another thing that's going on here is that at any stage you can forget. You can forget where the eggs were. At literally any stage, even in long-term memory, you can forget where, what something significant was. Here's the use of this. So what's significant about this, aside from the fact that you can forget at any time, uh, for one thing, you can see that it requires repetition in order to encode in long-term memory. It also means, sorry, I'm kind of blanking on this. It's because my long-term memory, I'm in here right now. Um, Retrieval, repetition, encoding into long-term memory. Oh yeah, here's the thing. You only encode long-term a tiny, tiny fraction of your daily experiences. So you've already forgotten most of yesterday. You've forgotten most of last week. You only encode things that you pay attention to, that you repeat, that you retrieve, and encode long term. And again, at any phase, you could forget that. So your experience of your life, your memories of your life, are a tiny, tiny, tiny fraction of your actual experiences. And I think that's actually important to understand as a big picture concept of you remember supposedly important things. You remember the things that you paid attention to, right? And repeated to yourself. One last thing that I can give you out of this slide is this. I can kind of manipulate your short-term memory or help you manipulate your short-term memory. Your brain likes sets of 3. If you want to shove something into short-term memory, the most you're going to get out of it is probably 3 sets of 3. So again, I never really recommend using short-term memory for exam preparation, shoving something in your brain right before an exam and then brain dumping it into a blank spot on a page is not guaranteed to get you very far, so don't rely on it. But if you've got nothing else, you can figure out what 3 sets of 3s are and shove them in there. Okay, now I really wanted to add a little bit better understanding for what memory actually is beyond what your textbook was showing you, or beyond what these previous slides anyway were showing you. Now remember, we need the hippocampus to do this. We need a working hippocampus and a working amygdala in order to make these memories, but I wanted to show you what making these memories actually looks like. So here's one sort of conceptual diagram. I'll go ahead to this one real quick. What we say we're doing when we're encoding memories is we are actually developing synapses between neurons. So each of these little images, there's a cell body, and then that little line going this way represents an axon. So this is just going to be a neuron connecting to a neuron, connecting to a neuron, connecting to a neuron, connecting to a neuron in a circuit, right? And all of those circuits are made up of synapses between them. The formation of new memories means the formation of new synapses, new connections between neurons. And again, that is aided by the hippocampus. The hippocampus is going to activate this circuit of neurons appropriately. So to go back to this conceptual diagram, here's things you already know. And then you're trying to make some new connections when you learn. Literally, you're trying to make new synaptic connections. The hippocampus enables us to make these new synaptic connections. So this is you while you're studying. You're trying to build a new synapse. And with repetition, eventually, you can make a new synapse. And then what we learn from memory degradation is that you can also ultimately lose synapses. So this is what you should be mentally sort of considering when you study. You need to repeat that information at sort of specific timing intervals. Repeat it over days, repeat it over hours, repeat it over weeks, so that that synapse stays strong. That's what's actually going to be physically necessary for you to create a new memory. And again, this is a little bit extra compared to what I used to cover for this part of the lecture, but I think it's actually much more functional in terms of how you can understand what memory really is. So again, your hippocampus will activate this entire circuit depending on you trying to recall specific information. Different neuron circuits will be activated. Another thing that's a little bit extra compared to the old lecture is talking about procedural memory. Uh, we discovered part of how we discovered the difference between episodic and procedural memory is by studying a man who, let's see if it's in here. Did I actually put him in here? There's a great article I put in here. There's a guy named, I think Henry Molyneux was his name. Um, I could be saying his name wrong because I only ever learned him as patient HM because he was still alive when I first started studying this. He had severe temporal lobe epilepsy, and they had to bilaterally remove his bisomedial temporal lobes, which, if you remember, is where his hippocampus was, bilaterally, both sides. What they found was he couldn't make any new memories. He couldn't do this, at least not episodic, but they could train him in physical tasks. So this task right here that's being represented, let me get my pointer back. So what this was he wasn't looking directly at the star, he was looking in a mirror, and he couldn't see his own hand or the star directly, he could only see the reflection, which showed it upside down. And so the first day, the patient at HM tried to do this task. They said, okay, I want you to draw inside this line, outside the first star, inside the second star. You have just got to try to stay inside the lines here. And doing that while you're looking at a reflection instead of the reality is a real challenge. So the first time he was really slow, it was really difficult, the line wavered over and over, but they kept repeating this day after day. And by the third day, patient HM is saying, wow, this is an easy task. He doesn't have any episodic memory. He has no memory of the event of physically attempting this task, but he is very capable physically of this task. So we determined at that point there is another type of memory that is procedural, that is mechanical, that is physical, and it is not stored, it does not utilize the hippocampus at all. And since it's a fine-tuned motor movement, that sort of tracked it back to that cerebellum and our understanding of the cerebellum. So again, this is beyond the original lecture, but as future nurses, you're going to have to learn a number of physical activities. And you're going to start by studying them episodically. First, I'm going to take this thing, and then I'm going to take this thing, and I'm going to wrap this around them, and then I'm going to puncture this vein in this way from this angle. But you're going to have to get it into your procedural memory. So my recommendation is always going to be start by doing the physical thing, physically practice it before you get tested on it, before you get into skills lab. Make sure that you have a physical way to experience that before you get into a scenario where they're testing you on that skill. All right, last topic is consciousness. And really, I think the more important term is reticular activating system and reticular formation is really what we're talking about when we talk about consciousness. The way that your textbook is using the word consciousness sounds very philosophical, but really they actually just mean you are awake, you are aware of sensation, you have voluntary control of motor activities, activities of higher mental functions, you're aware, you have reflexes, it's really just that you are awake and in control. That's what they mean by consciousness. They don't mean to be or not to be. And it's a valid term to use medically. One day we are going to talk about level of consciousness in terms of how somebody's doing after, say, a brain injury. If somebody has intracranial pressure, their level of consciousness is actually going to decrease. So when we say consciousness, we say, are they conscious? Are they aware? Can they physically move themselves? That is all very relevant clinically. The thing that is controlling consciousness in large part is the reticular activating system. And I am going to, just fair warning, use reticular activating system and reticular formation exactly the same. They are essentially the exact same thing. The reticular formation is arguably the specific nuclei involved, whereas this is considering it as a system. Uh, that's it. That's the only difference. I don't really think it's a different thing. So I went and I stole these pictures from my sleep lecture, which were in turn stolen from, and I think I've got some citations. If not, I'll go track down those citations for you. So this was from a resource that I used to utilize in my lecture, still utilize in my sleep lecture. Where's my... That's weird. Okay, I lost my ability to have a cursor. Oh well. So here's a reticular activating system. What it actually is a number of different nuclei, collections of cell bodies. All of these different nuclei are going to project into the forebrain. They're going to release different um, neurotransmitters. This one's norepinephrine, this one's acetylcholine, that one's serotonin, there's some dopamine, there's some histamine, there's more acetylcholine. All of these different neurotransmitters are projected into your forebrain to increase your level of consciousness, which is to say, make you be awake and aware and have voluntary control over your body. These are your awakeness nuclei, is kind of how I personally phrase it. Now, the reason I went and I stole this from my sleep lecture is that your reticular activating system is inhibited during sleep. This is actually your mechanism for sleep. So I just get to shove a little bit of super cool sleep information in there. So this VLPO right here, again, don't worry about the individual nuclei names. This is releasing GABA. GABA is your main inhibitory neurotransmitter. GABA is going to slow things down. It's going to inhibit. It's going to depress, not in the psychological way of I'm sad, but in the physical way of suppressing. Depression in the brain is suppression, inhibition. So by inhibiting the reticular activating system, that is actually what physically makes you sleep. This is the way your textbook illustrated it, and it's just not good. So that's why I pulled much, much better information in for you. So they're just showing the reticular activating system, the reticular formation, as this variety of sort of like almost like a tract. They kind of make it into one big physical thing, and they're just wrong. The textbook's just wrong about what the reticular formation is. There's part of the reticular formation. It's just wildly inaccurate. It's bad. And I think I've pretty much conveyed all of this. It's a continuum ranging from alertness to sleep. And again, as I mentioned earlier, brain injuries are going to impact that and suppress that reticular formation or reticular activating system. And that was it. Let me know if you have any questions. Again, this is the first time that I've lectured a bunch of those slides, so I imagine there are a lot of questions, so please post those or send them to me. And yeah, I hope that worked for you guys. Thank you so much.